Here we go. Again, if you didn't do the quiz, foolish would be copying it out as we go. Who's my favorite student? Sadly, not Mila. Here we go. Good old Anne Sirky. Key idea here was constant speed, so I underlined that. And I said to myself, okay, they want the coefficient of friction. They want me to find the mu. This is definitely a job for a free body diagram. I said gravity down. I said normal force up. I have an applied force. And since it's constant speed, and that means it's a tie, I actually tried to draw friction the same size as this. In fact, the first thing that I wrote was this. Friction is 12 newtons long. Large. Magnitude. It's 12 newtons. Then I said to myself, friction is what times what? Mu times the normal force. And so to get the mu by itself, I said it's going to be 12 divided by the normal force problem. I don't know the normal force. Oh, but look. I saw another force that has to be the same size as the normal force. I said it's going to be 12 divided by mg. Did you all get, I think it's A, yes? I'm just going from memory. I didn't actually calculate that one. 2 marks, apparently, for that 1 mark multiple. Well, you had to do 2 marks worth of work, but I turned it into a multiple choice question. Number 2, now we have air resistance. I had to phrase this very carefully. First of all, I'm falling downwards, get the obvious one, gravity. Because I'm falling downwards, I know air resistance is pointing up, and because I'm accelerating downwards, I know air resistance is smaller. I had to add those phrases because a couple of years ago, I had a student, well, Mr. Dewick, in the parachute example that we did, air resistance was bigger because we were slowing down. And I said, good point. So I added the phrase accelerating downwards, falling downwards. So we end up with this, mg minus f air equals ma. Matt, what was this question asking me to find?
Acceleration.
How? How will I get the a by itself?
Oh, divide by mass.
Now, as far as I'm concerned, Diego, I can either give you f air and say divide by the m to get the a by itself, or I can give you the acceleration, get the f air by itself. Both of those are fair game, because I think the tricky part is getting the equation, but once you have that, hopefully you're at the stage now where I can get whatever I need to by itself with this formula manipulation shtick. Anyways, I agree with you. A is going to be mg minus f air all over m. It's going to be 0.62 times 9.8 minus, do I need to multiply that 1.4 times 9.8? No, it's a force already. Thank you very much. All over 0.62. There is a built-in error check. If this was a vacuum, what's the maximum the acceleration could be in free fall? 9.8. It's going to be less than 9.8. In fact, I'm doing some quick math in my head. I think you're going to get something in the 7 point something or 8 point something range, I think. But that's a real guess, but I think. Let's find out. 0.62 times 9.8 minus 1.4. Close off the top. Divided by 0.62. Did y'all get 7.54? I would take 7.5. Units, meters per second squared. If you got that, give yourself 2 out of 2. Otherwise, I would probably give you a half mark for that line, half mark for that line, half mark for the numbers, and a half mark for the answer. Kenna, what's number 3 asking me to find? The what force? The what force? First thing I did is I said, oh, this is easy, F equals ma. And then I said, okay, F equals 1200. Oh, even though technically this is asking me to find the net force, what am I going to spend most of my time finding? Yeah, I went like this. I drew a little line. I said, okay, A equals question mark. Well, I see VI is 0, VF is 15, D is 85. I said, you know what? I can go VF squared minus VI squared all over 2D. I can go VF 15 squared. You know what? Do I need to type the minus 0 squared? That's not going to change anything. So I just closed off the top. Divided by bracket 2 times 85. close off the bottom. Did you get an acceleration of 1.32352? I'm going to write 1.32, but I'm going to store this on my answer button. And then I walked it over to here. I'm going to write 1.32, but what button am I going to hit on my calculator? My answer button. It's way less work, and it's more accurate. So 1200 times answer button. Do you all get 1580? I'm going to go 1590. I'm going to go to 3 sig figs, but if you said 1588, I'd take that. Units, newtons. I would probably give you half mark if I saw that, half mark for that, half mark for that. I would probably give you, oh heck, 1 mark if I saw that, and a half mark for the answer. Now here's what that means, Diego. Supposing you got the acceleration wrong, or you couldn't find it. If you put that number, first of all, you got it wrong. If you put that number there and multiplied it by 1200, I would give you 1.5 out of 3. Oh, it's out of 2, Mr. Dewick, not out of 3. So how about I do this, Mr. Dewick? Let's go 0.5 for that, 0.5 for that, 0.5 for that, 0.5 for the answer. I would give you 1 out of 2, or let's suppose you knew you needed to find the acceleration and you're blanking. Can't remember how to find it. On a test, you can write me a note, Mr. Dewick, I can't find A. Let's assume A is 4 meters per second squared, and if you put the 4 there and you crunch it, I would absolutely give you marks for this half, because that's what I'm assessing. Or if there's a part A and a part B to a question, and you know you need part A to do part B, but you can't remember how to find part A, make up a reasonable answer for part A, move it down to part B, write me a note just so I catch it. I'll give you full marks for part B. Don't leave stuff blank. If you can, it'll help it, Caleb. Is that all right? Caleb, what's number 4 asking me to find? Yeah. But what am I really going to spend most of my time finding? Yeah. Because I started out going like this. VF, oh, wrong color, Mr. Duke. VF equals question mark. And I did see VI is 0. And I saw D is 16. You know, either time, I could get V final if I knew time, but I figured we're doing forces and stuff. Yeah, I drew a little line down the middle of the page and I said, okay, A equals, typically what in my notation, Ethan, I put a question mark next to the main thing I'm trying to find. If I'm trying to find something else to get the main thing, I put a blank as though this is a blank I need to fill in order to answer the actual question. Whatever works for you, but this is my stupid notation that works for me. How am I going to find A? You know what this is a good job for? I think so. I said, okay, gravity down, normal force the same size as gravity. There's an applied force of 56, and it looks like there is friction because there's a mu. I said, who's winning? F applied minus friction equals MA. I said that means that A is going to be F applied minus friction over M. Although, Paige, I didn't bother writing friction again. Instead, on the next line, I said, hey, that's going to be mu times the normal force. Although, then I thought to myself, I don't know the normal force. Oh, but look. I know another force the same size as the normal force, Paige. Which force is going to be the same size as the normal force here? And so I actually just kind of went, yoink, mg. And I got A equals 56 minus 0.24 times 12 times 9.8 all over 12. I got no idea what the answer is here. Bracket 56 minus 0.24 times 12 times 9.8. Close off the top, divided by 12. Did you get an acceleration of 2.31466? I'll write 2.31. And now I walked that over to here, and I said, you know what? This is going to be VF squared equals VI squared plus 2AD. Although VI is 0, I didn't really need to bother writing that. And how to get rid of a squared square root. I said VF is going to be the square root of 2. I'm going to write 2.31, but you know I'm using my answer button. Times 16. I went 2 times answer button times 16. I got 70 something square root. Did you all get 8.61? 8.6 something? If you got that, I would give you 3 out of 3. If you did not, I would probably do something like this. I would definitely give you a half mark if I saw that. I would give you a half mark for the numbers and a half mark for the answer. Here, I would probably give you a half mark if I saw that equation, a half mark if I saw you got the A by itself, and then a half mark for the answer. Something like that. How many of you got that right? Well done. I don't know if you realize, but before Christmas, because this is actually a multi-step question, because not only are you having to find something in order to find something, you have to create a free body diagram. This would have terrified you. You've come a long ways, folks. Proud of you. Although I'm not as proud of you as I am proud of my artwork in drawing this lovely skier. I mean, look at the motion, Amy. It just breathes life. Nothing. Okay. This is actually, skiing is a tricky free body diagram. It wants the acceleration. I said, okay, I'm going to have gravity down, normal force up. I'm pretty sure the same size. I definitely said I'm going to have friction this way. And I often see kids, they want to put the 110 pointing that way, but you have to be careful. What are you, when you, with your ski poles, push backwards, what are you pushing on? The ground or the snow? What's pushing on you? Forces come in. The ground or the snow pushes on you. And so that 110 on the skier, heck, let's call that F applied, for lack of it, F push, whatever. But I know it's going to point forwards. This is a forces come in pairs, Newton's third phenomenon. Now that I've got that, this isn't too bad. I think I would say to myself, who's winning? Who's losing? Equals MA. Look up, everyone. As far as I'm concerned, Grace, I can give you mu and say find the acceleration, or I can give you the acceleration and say find the mu, which is hidden inside the friction. So you would get friction by itself first, and then you would have mu times the normal force, divide by the normal force to get the mu by itself. I think, Josh, either of those now is fair game. Because as long as you can set up the equations, get whatever you want to. Oh, and I guess I could give you A and mu and find the applied force. How hard are you pushing? Fine. Meanwhile, I asked for A. A is going to be F applied minus mu times the normal force all over M. A is going to be F applied minus mu, I don't know the normal force. Oh, but look. This time it's mg all over m. A is going to be 110 minus, hey, what's mu? Snow should have a low mu. Snow is pretty slippery, but there is some friction. 47, 9.8 all over 47. I have no idea what the answer is. 110 minus 0.11 times 47. I wrote a 10. I'll go back and fix it in just a second. By the way, I would have caught that. If I had not caught that, how would I have known that I probably made a mistake just looking at my answer? Or friction is winning, but it's snow, and Mr. Dewick tries to make up reasonable numbers. It's unlikely that when you're skiing, the snow is dragging you down so much that you just can't push yourself to accelerate. So I would have caught that. You get 1.26? No? I see you need some nods. Yes? No? Yeah? Okay. 1.3 meters per second squared. If you got that, 3 out of 3. Otherwise, 1, 2, 3, 4, 5 things. I'd probably go half mark for that, half mark for that, half mark for... You know what? I'd probably go 1 mark for the original equation, because that's the key. Half mark for that, and then a half mark for the answer. Steady speed. This is a job for a free body diagram. Seems to me we have gravity down, we have normal force up, it wants us to find the applied force. So I'll even put a question mark there in my free body diagram to say, oh, which force am I missing? Am I going to draw friction bigger, smaller, or the same size as the applied force? One of those answers is correct. Which one? Steady speed, the same. Otherwise, smaller or bigger, I need more information. I would also, so here, steady speed, A is 0. I would also have no problem giving you an acceleration and saying, find F applied. It'd be a little tougher. But yeah, it's going to be same size. In fact, I'm going to start out by saying F applied is the same size as friction, which means it's the same size as mu times the normal force, which means I don't know the normal force. Oh, but look. It's the same size as mu mg, which means I can go F applied equals, hey, what's mu? 0.32. What's m? 20. G, 9.8. By the way, this would be this equation right here. This is the equation that describes how hard you need to push on any object to keep it sliding across the floor at a steady speed. It's whatever the coefficient of friction of the floor is times the mass of the object times 9.8. That's how hard you push. And you can all figure that out intuitively. You've all pushed something at a steady speed, but there's the calculation. Y'all get 62.72, I'm going to go 62.7 newtons. If you got that, I would give you 3 marks out of 3. Otherwise, probably 1 mark, half mark, half mark, half mark, half mark. I think that adds to 3. It does. Can you give yourself a lovely score, please, out of 1, 2, 3, 15? And if you'd be so kind as to pass them inwards. Forgot to do that. And the person in the middle can put them in a nice, neat pile, all facing the same way. Stuff out. Just a reminder, here's what we said last day. First of all, I gave you my best, worst joke ever. Waha. Really what I said is, if you give me more than one mass, it's a fairly easy adjustment because we're not going to let you jerk on the rope. It's going to be smooth accelerations, which mean that they'll have the same magnitude of acceleration, which means I'll adjust my winner minus loser equation. Diego, it's going to be winner minus loser equals the mass of all of them times A. The first time I wrote it as M1 plus M2. If there's 3 masses, I would write M1 plus M2 plus M3. If there was 4 masses, I would write M1 plus M2 plus M3 plus M. You know what? M all times A. And then we said, here was our key. If I want to find the acceleration of everything, I'll write a force equation for everything. We say that again. If I want to find the acceleration for everything, I'll write a force equation for everything. But if I want to find an individual force, I'll look at an individual mass. That's our strategy. And so we can even handle more than 2 masses. While you're there, I do want to point out this question here, I like, but also in the question we did, we got the A by itself. In your homework, and I'm deliberately not doing an example with you, I'm going to see if you can figure out. In your homework, there's a question where they give you the acceleration and they ask you to find the coefficient of friction mu, which is hidden inside of friction. Mila just gave me a stink eye. It's not bad at all because I think, Mila, first of all, you'd get friction by itself, swappy dance. And then friction is what times what? Mu times the? I think you'll just divide by the normal force. Mu's by itself. I don't know the normal force. Oh, but look, you have to do a bit more than that. But if you're ever trying to find mu, you'll end up dividing by the normal force once you have the mu Fn by itself. Let's do 3 masses, Mila. Mila, what does part A want me to find? What does part B want me to find? Keep reading. In. Oh, there's 2 ropes. There's going to be 2 different tensions. Okay. Again, I don't care how you want to do this, but my habit, Mila, is I start on the left and just work my way to the right. So what are the forces acting on mass 1? Get the obvious one. Hang on, we need to pause for a second. Which way is this mass going to accelerate? To the left or to the right? and why? How big is the mass on the left, Mila? How big is the mass on the right? Which one do you think is going to be winning? I'm going to make the assumption that we're accelerating in that direction. Let's file that away. Meanwhile, what are the forces acting on mass 1? Get the obvious one. Is there more than one mass? I'm going to call it M1G. What else? Is there more than one rope this time? You know what? I'm going to call this tension left rope. How about TL? And I'll call the other rope tension right. Anything else? Nope. Sahara, let's do the second mass. What are the forces acting on it? Get the obvious one. Is there more than one mass? M2G. What else? To go with mass number 2. What else? I don't see a tension 2. First of all, okay, which way would friction be pointing? Because it's sliding to that. That's why I had to ask before we started who's winning, because otherwise we don't know which way to point friction. If this is sliding to the right, I'm pretty sure that there is a friction to the left. Do you mind? I'm going to call it friction force number 2 to go with mass number. Yeah, we go. What else? Well, let's complete our forces come in pairs. We have a rope. It seems to me tension left is tugging it to the left. And there's one more. I'll call it tension right, second rope. So if you look at this, Diego, the 1 kilogram mass is being accelerated by that tension. The 2 kilogram mass is being accelerated by that tension. Hey, Diego, what are the forces acting on this mass? Get the obvious one. Is there more than one mass? Can I call it M3G? What else? Which one? I think I'd call it tension right because I think that's the same rope as the other one and forces come in pairs. Is that okay? That's it. Pause. In your brain, can you imagine if I'd thrown this free body diagram at you 3 weeks ago, how horrifyingly terrifying it would look? And I hope you're seeing, this is why I preach at you, Grace, if you go systematically, these aren't bad at all. But if you're just trying to do it willy-nilly in no kind of order, and you're going to miss stuff for sure. So I'm going to strongly encourage you kind of do it my way. Is that all right? Good. Isabella, who's winning? First of all, whoever's making the drum solo with their feet, can they stop? Who's winning? I couldn't hear you. You need to talk louder each time. I'm seeing this. Which is the mass on the right? Mass number what? Which force is winning then? M3. Oh. Well, here's what you're saying, and you're right. Anything that once it gets to this side is pointing down will be a winner plus. Anything that once it gets to this side is pointing up is going to be loser minus. Here we go. Winner. Oh, and I should point out, we're writing an equation along the rope, just like we've done for all the other ones. In this case, there's going to be a couple of changes of direction, Mila, because of the pulley, but that's okay. Winner, M3G. And then I run into tension right. Winner plus, loser minus. Loser minus. And then I run into this tension right. Follow it, follow it. When it gets to this side, I think it's going to be winner plus. Then I run into friction force number 2. Follow it, follow it, follow it. I think when it gets to this side, it ends up pointing. So, loser minus. Then I also run into tension left. Winner plus, loser minus. Now, here's where it gets a bit weird. Look up for a second. A lot of kids say, well, tension right pointed up and it was a loser. Tension left is pointing up, so it must be a loser as well. But if you follow it, follow it, follow it, follow it, follow it, follow it, I think when it gets to this side, if you just kind of imagine the arrow, I think it's pointing down. I think that one is a winner plus. You see that? And the same with this M1G, Ethan. I've seen kids say, well, M3G pointed down and it was winner, so this must be a winner. But if you follow it, I think when it gets over to the other side, I think it would actually end up pointing up, lose, or minus. What's that going to equal? M all A. Why? Because I have forces from all three masses on the left. I better have all three masses on the right. Let me scroll up now. Well done. Is there a long weekend coming up? Everybody, come on. Pencils down. Stretch it out. Oh, wow. Really stretch it out. Why are we really stretching out, Isabella? Twice? This is like a double spa treatment or something like that. We not only lose the first set of tensions, we lose the... Oh, except I wrote an R there for some dumb reason, Mr. Dewick. But thankfully, I still would have crossed it out anyhow. Okay. Good. Mr. Dewick, we get to the test on those questions. Are we allowed to put our pencil down and stretch? I encourage it. Why not? It'll be right about the time when you need it anyways. Hey, Grace, how would I get the A by itself? By the way, pause. Or I could give you, sorry, Mila, I could give you A and ask you to find mu, which is hidden inside there. You would swappy dance plus that over, minus that, divide by the normal force, and you've got the mu by itself. It's doable. It's a little longer. What? I'm going to divide by? Yeah. So I'm going to get this. A equals, and I'm going to draw a little fraction line. It's a long weekend. We're going to cut corners. I'm going to go M1 plus M2 plus M3, and I'm going to go M3G minus pause. Amy, I'm not going to write friction force number 2. Instead, I'm going to say friction is what times what? I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. Oh, you're the first student who said M2G. Everyone else I've had to say, there's 3 mg's on the diagram. Beast, you just made my day. So minus mu M2G minus M1G. On a test, my next step would be to write in all the numbers. You guys got a long weekend coming up? Get your calculators out. Is this a fraction? Brackets around the top. See if you can go straight to, from the diagram, entering the numbers into the generalized equation and get an answer. I'm going to do it up here as well. Oh, built-in error check. It's going to be less than 9.8. Be really careful with your masses. So bracket, oh geez, bracket 8 times 9.8 minus 0.25 times 9 times 9.8 minus 1 times 9. I got something that ends with a bunch of ones. I got 2.58611111111. We're going to write that. In fact, I'm going to write. Is that yes? Got that? Alec, yes? Type with 2 hands. And I'm actually not joking. I find you'll make far less like typos on a test doing 2-thumb typing than doing got the hair 1-thumb typing, and it's such an easy fix. Right? Can you? Sorry. Don't clear your calculator. Let me pause the video for a second. I'm going to write 2.5861 repeating. And then I'm going to write 2.59 meters per second squared. And the reason I jotted down a longer version is I think I'm going to use it. And I think I'm going to use it more than once, so my standard storing it on my answer button isn't going to work. Because... Ooh. Paige, what does part B want me to find? Both tensions? I'm going to do that. I'm going to find tension left on the left and tension right on the right. Mr. Dewick, I want to find tension left on the right-hand side and tension... Oh, do yourself a favor and be moderately organized. Everybody right now, look at your free body diagram. Find the tension L's, in the TL's in your free body diagram. Stare at yours. Oh, I'm waiting. Ethan's still writing like mad. Couldn't you just get it from your calculator without looking? Oh, shut up. Okay, see the TL's in your look at your free body diagram. See the TL's? Which mass would I obviously want to use to find tension left? Which one is way cleaner and is probably easier? Yeah, I'm going to use mass 1. I'm not going to use mass 2. So which way is mass 1 accelerating? Now, one person said down, one person said up. The good news is one of them is correct. Is it accelerating down or up? I think we decided that winner was down on the right with the 8. Yes? So which way is mass 1 accelerating? Which force is winning? Looking at mass 1, look at mass 1. Which force is winning then? Which one? There's tension.
R left.
Wow. Tension left. Which force is losing? Look. And what's that going to equal? M1A. We're just doing our equation for that mass. Tension, change colors, Mr. Duick. Tension left minus M1G equals M1A. Is that okay? How would I get the T by itself? Plus it over? Plus the M1G over, yes? It's going to be M1A plus M1G. It's a long weekend, and I'm trying to cut corners. We're not going to write out the numbers. Let's go straight to our calculators. How big is M1? 1 times a answer button, yes? Plus 1 times 9.8. Mr. Duick, did I really need to type the 1 times this? Probably not, but just in case. Okay, so you're going to your calculator. I have no idea what the answer is. What'd you get, Sahara? Anybody else? 12.4? Paige, 12.4? Mark, 12.4? Ethan still typing? Okay. Units, it's a force. Newtons. Now, I can no longer use my answer button because now my answer button would put in a 12.4 and not a 2. Okay. Find the tension rights, the TRs in your free body diagram. Which mass would I probably use to find tension right? Yeah, I would not use mass 2. By the way, you totally could, but why? So much more complicated. Which way is mass 3 accelerating? Who's winning? I think it's M3G minus tension right equals M3A. Is that okay, Will? Hey, everybody, what kind of dance? Wow. Sesame Street is brought to you today by the word everybody. The word everybody, hint, means more than one. Hey, everybody, what kind of dance? I didn't see some lips move, so we're going to, back row corners. Here we go again. Hey, everybody, what kind of dance? In other words, boom, boom. I think we're going to get this. Tension right is going to be M3G minus M3A. Mr. Duick, I don't have my answer button anymore. Yeah, what was M3? How big was it? Was it 8 or 9? Was it 8 or 9? 8? I'm going to go 8 times 9.8, and then I'm going to go minus 8 times 2.586. I can't do a 1 repeating, but I'll just type like 5 or 6 ones. That's going to give me accuracy to at least 4 sig figs, and I'm going to be good. In fact, I get 57.7. I have a feeling it might even be 1 repeating if I use the 1 repeating to begin with, but I don't know. Is that okay? Oh, put a box around that one too. So in this lesson, I've done everything in the homework except get a mu by itself when there's more than one force. What's your homework? Don't circle stuff yet. I'll tell you when to circle stuff. 1, 2, and 3 are identical, except 3 has friction and is tougher. So I'm going to say start with that. See if you can get that. If you can't, try number 1 or number 2 for practice. Skip 4. 5 is good. 6 is good. Put a star next to number 7 and circle it. I think most of you can get 7A. 7A says find the acceleration. Psst, look up, look up. Here's your hint. Treat this as a single 14 kilogram mass. But then B says find the coefficient of friction between the 2 kilogram mass. I took this from an old Physics 12 scholarship provincial exam. See if you can have that aha moment. 8, here's an example with 3 masses. Turn the page. 9, here's an example where you're finding the coefficient of friction. It's at rest, so what's your acceleration? So it's going to be a tie. When you do your winner minus loser, it's going to be a tie. Or it's going to be winner minus loser equals M0, 0. Number 10 is a little bit tougher. Now, instead of everything being at rest, I'm giving you the acceleration and still staying at the mu by itself. Put a star next to number 12. This is also from an old scholarship exam. So if you don't get 12, I'm not going to freak out at all. Most of you won't get it. But I'm curious to see who has that aha moment. And if you don't get 7B, I'm not going to freak out. But I'm curious to see who has that aha moment. My angels, the class is yours.